Hey guys, Mr. Perez here. This is Module 5, Lesson 4, the area of all triangles using height and base. This is my second time recording this. The first time I did not have sound, so got to do it all over again. So we have spent the last two lessons, Lesson 2 and 3, were on triangles. So just a quick review. We have this blue triangle. The blue triangle is called a right triangle because it has that 90-degree angle. And we can find the area of a right triangle by knowing the base and knowing the height. So if this base was, let's call it 4, for example, and maybe this was a height of 3, then I could find the area of this right triangle by multiplying 4 times 3, but then dividing by 2. So the area of this one would be 6 units squared. Same thing with an acute triangle, like this pink triangle is an acute triangle. Let me go ahead and make a minor change to this. So if I were to make the base roughly the same, so let's say this base is 4, and then I want to know the height of this triangle. Well, the height, remember, is always going to be perpendicular to the base, going as high as it goes. Notice this is a right angle. And then if I were to, let's call that also 3, then it would turn out that both of these triangles have the same exact area. 4 times 3 is 12, divided by 2, and you get 6 units squared. So another way that you might do this is if you were to know both sides, like let's say this was 1 and this was 3, then you could calculate the area of a left triangle first using 1 as the base, and then you could calculate the area of the right triangle using the 3 as the base. And notice that they would both have a height of 3. And then you add them together, you would get 6 anyway. So my preference is usually to just add the two bases. So if they ever separate the bases like this for you, just go ahead and add them together, and then you get a base of 4, and that's what I use to solve the problem. All right, moving on. Opening exercise, draw and label the altitude of each triangle. I want to remind you guys that the word altitude actually is just a synonym for height, the height of the shape, the height of the triangle. In this case, question A, the height. Remember, we always want to identify what is the base. The base is right here. In fact, the base could be any of the 3 sides, but I like calling this the base because I could go straight from this point and I could bring it straight down, forming a 90-degree angle, and that would be what is known as the altitude. That would be the altitude. Now, let me show you a situation where if I were to rotate this, so let me go ahead and draw this first. So I'm going to go ahead and draw, and then I'm going to rotate it so that it's facing this direction. Try to keep it the same size. And if I were to have this triangle, then there's nothing that says that I can't call this the base. If I call this the base, certainly it's going to be a different size than my original base. But this time, my height is actually going to be a bit longer, as you can see. So if I were to find the area of this triangle, they would come out the same. Doesn't matter what base and what height I use as long as I'm consistent. So the black triangle would have a height right there, and it would have, or an altitude, and then the base would be right here. So using that base and that height will find me the area, or on the pink triangle using that base and that height. I could rotate it in any different direction, to be quite honest. So the altitude for B. So let me do a similar thing here. Let me go ahead and recreate this triangle, and then I'm going to rotate it. And there's actually 2 really good ways to rotate it. I could rotate it so that the short side is on bottom, or that the long side is on bottom. I'm going to choose this way. So try to make it the same size. And you can see it's the same exact triangle. Just this time, I can identify that the base is this bottom part. And the height or the altitude is actually the side length of this triangle. Just so happens in right triangles, the altitude is basically the side. So the altitude, also known as the height. In question C, now this one, I don't have to do any rotation because I have a nice flat base right here on the bottom. But what's different about this one is that if I were to start at the topmost point and go straight down, I end up outside of the original triangle. So I could always just extend this and it would form a 90-degree angle there. So the altitude is right here. I'm just going to call it alt. That's the altitude, even though it appears to be outside of the triangle. This would still be the base, just this little section here, from here to here. It's not counting the extra dotted lines. So I do really want you guys to understand that. I saw some people make this mistake. If I want to find the area of this triangle, I am focusing on just the part that is solid line. So this is my triangle. My triangle falls only in this section. I'm not going to count the dotted line section that I left away. Okay, moving on. Exploratory challenge. So these exploratory challenge problems, unfortunately, they just don't work through these videos. So I'm just going to kind of give you guys the main point, the main ideas that they were talking about in this section. So if we start out with a rectangle, and let's say the rectangle has a base of 10 and it has a height of 4. How would I find the area of this rectangle? Base times height. Right? For a rectangle, I find the area by multiplying the base times the height. In this problem, I end up getting 10 times 4, and the answer would be 40. The area would be 40 units squared. 40 square units, 40 units squared in the rectangle. And then what they're really trying to get you to understand is that, hey, if I were to cut this in half, so I'm going to take this shape and I'm going to cut it in half right there. Nice diagonal. Of course, as you can see, now I have two equal triangles. We had that problem the other day about the soccer field. And if we cut the soccer field in half, is it cut it in half diagonally? Is it fair? Do they both have the same amount of work to do on the soccer field? The answer was yes. Yes, they have the same amount because I cut it in half. When you cut something in half, you get two equal pieces. So now focusing on the bottom half of this. So the bottom half would be here. This would be a right triangle. And this right triangle has a relationship to the original rectangle. So this blue section is half. So what does half mean? Half means divide by 2. So if I were to take the triangle, so now I'm focused on the triangle, and I want to find the area of a triangle, I know that it's area equals base times height because it used to be a rectangle, but I'm cutting it in half. So just a reminder, we've actually worked on that. So let me go ahead and work it out. So I know that base times height is 40. I'll go ahead and show my original work, but then you're going to divide it by 2. So you end up getting 40, which was the answer to the rectangle problem, but then you're going to divide it by 2, and you're going to get 20 units squared. All right, that's the main idea of the exploratory challenge. So I'm just going to go ahead and move past the exploratory challenge problems and scroll all the way down until we get to the exercise problems 6 through 8. These are just going to be some more of your triangle type problems. I ask that you guys go ahead and work on number 6, 7, and 8. Try your best on your own. Pause the video right now and get these problems done. Okay, so you should have paused the video and now you're back and we're going to work these problems out together. So question number 6, calculate the area of each triangle. You'll see this message, figures not drawn to scale. That just means that obviously this length right here, this is not 10 inches, right? It's much smaller than that. It's not drawn to scale. So question number 6. We have to identify the base. First of all, what is the base of this triangle? Remember, we are not counting the dotted section. We are only counting this section over here. Do not be fooled. Do not use all that extra information. So right here is what we're aiming for. And the base is basically this 24. The 6 doesn't tell me anything. The 6 is the length of that extra section, but I don't really care for that. And then I want to know the height, and I want to figure out which one is the height. And hopefully you identified this one as the height. The height is the altitude, which is going straight up and down, perpendicular to the base, even if it's outside of the triangle. So what that means is that this number 10, don't need it. This number 6, don't need it. Right? So area equals base times height divided by 2. The base we identified is 24. The height we identified is 8. And then I'm going to simply divide it by 2. A way that I like to do this with mental math is I like to take 2 of the numbers, any 2 that are really simple to me. And if I could divide it by 2, I just go ahead and do that. So I end up actually getting 12, because 24 divided by 2 is 12, and then times 8. So the final answer, 96. And I did that all with mental math. Of course, you can use a calculator if you choose to. So 96 inches squared. Question number 7, we're dealing with fractions, so definitely be ready for fractions whenever they occur. The base of this triangle, I'm looking at it kind of upside down. If I were to rotate it all the way around, is 12 3/4, and the height is 9 1/2. So that means that this number 14 1/8 is not necessary. I don't need to know it. So I'm going to revise my formula a little bit. This time, instead of using base times height divided by 2, I'm going to use 1/2 times base times height, which is the same thing. Because 1/2, if I take half of something, it's the same as dividing by 2. And the reason I'm doing this is because this is a fractions problem, and I think it's going to be much easier to deal with. So if the base is 12 3/4 and the height is 9 1/2, now when I'm multiplying numbers with mixed numbers, like 12 3/4 is a mixed number, what I want to do is I want to convert it into an improper fraction. So 1/2 doesn't change. This converts. 4 times 12 is 48. 48 plus 3 is 51. So I get 51 and keep the denominator, which was 4. This one, 2 times 9 is 18. 18 plus 1 is 19. So I end up getting 19. And once again, keep your denominator. Right, so this is a moment for my calculator. So let me go ahead and take out the calculator. And what I'm going to do first is the top 1 times 51 times 19. So I'm typing in 51 times 19, and I get 969. And then on bottom, it's 2 times 4, which is 8, and 8 times 2, which is 16. And then if I want to convert that into a mixed number, I'm going to do a simple division problem. My remainder will be my new numerator, and the 16 will be the denominator. So 16 goes into 96. It goes in exactly 6 times. So 6 times 16, 96. Subtract, bring down. So I end up getting 0, bring down the 9. 16 does not go into 9. Don't forget to put the 0. And that I ran out of numbers, so my remainder is 9. The answer is 60, remainder 9, or 60 and 9 over 16. And this is feet. So feet squared. There's my final answer. The area of the triangle is 60 and 9/16 feet squared. All right, question number 8. Draw 3 triangles. Hopefully you gave this one a shot. And we need to make an acute triangle. We need to make a right triangle. We need to make an obtuse triangle, but they have to have the same area. So my trick here is understanding the formula. Area equals base times height divided by 2. In order for them to have the same area, an easy way to do that is for them to have the same base and the same height. So starting out, for example, with an acute triangle. So this is an acute triangle. And if I were to say, hey, the base is, the base is 6 and the height is 4. Then the area of that would be, well, 6 times 4 is 24. Divide that by 2. The area would be 12 units squared, right? So the area would be 12 units squared. Now, if I were to do a right triangle, remember a right triangle is going to have that perfect right angle. So start out by drawing that, trying to make them roughly the same size and the same height. I get a little assistance with my iPad. But if I were, once again, let's call this a base of 6 and let's call this a height of 4. Now, of course, the base and the height this time lead me to an area of 24 divided by 2, 12 units squared. All right, the triangles look different, but they have the same base, the same height, therefore they have the same area. Now, if I want to find the area of an obtuse triangle, now obtuse, in case you were confused, an obtuse triangle is going to look kind of like, well, not like that. Let me see if I get that right. Okay, try one more time. Okay, there we go. So let me just go ahead and make some adjustments to this. And there we go. We have an obtuse triangle. In fact, let me go ahead and manipulate this even further. So I want it to be exaggerated. And you can see it's just like a really wide open triangle. Like this triangle is really wide open. That angle is bigger than 90 degrees. Now, if I were to call this base, it's still 6. And I were to call the height, remember now the height appears to be outside of the triangle. Still forms a 90-degree angle, and I call the height 4. Now, with the height of 4 and a base of 6, it would once again have an area of 12 units squared. So there you can see it, 3 different triangles. They all look differently, but they would all have the same area because they have the same base and the same height. All right, so that wraps up the lesson, but I did want to give you a little bit of information about this, the problem set. So every time you're working on a problem set, it is practice. Immediately when you're done with the lesson, I would like for you guys to work on the problem set. Now, this basically has been our homework, but since things are shifting a little bit, I'm not really going to be giving you a homework grade for this for now. Things may change as we get closer to coming back to school, but I want you guys to work these out. If you look on the math website, you can still find the lesson videos, the ones that I didn't record. Since I'm not recording a homework video, you should look up the homework video that is posted there. You're just going to have to look for it on the math website, which is bit.ly/westside-math6. Let me go ahead, I'll write it right here. So it is bit.ly/westside-math6. So bit.ly/westside-math6, and you're just going to have to look for the lesson videos. All right, so I got interrupted by delivery at my door. I had to get up and go to the door, so sorry about that. It actually adds a little bit more editing time for me, which is unfortunate, but, well, that's the way things goes when I'm at home. So I wanted to give you guys some information here. Question number 1, one of my main expectations is that people are going to be using all of these different numbers, and remember, not all these numbers are important. Right? Some of these numbers don't need to be used because what do we need when we're finding area? We need to know the base and the height. The height is very easy. The height is right there. It's 8. The 15 and the 6, well, this is one of those problems that kind of has like a left triangle and a right triangle. So 15 and 6 both are important. What I would do if I were you, add them together to get your base of 21. So you should use a base of 21 and a height of 8 for a problem like that. The 10 is there to trick you. The 17 is there to trick you. Question number 2, there is a number there that's meant to trick you. I'm not going to tell you which one it is, but you should only be using 2 of those numbers, which are the base and the height. Question number 3, again, we have some extra information that we don't need. Remember, we only need the base of the triangle and the height of the triangle. So do not make the mistake of including the dotted section. The dotted section is there to help you identify the height. But this blue section that I'm highlighting, that's the only section you care about. So make sure you use the appropriate base for question number 3. And then finally, little hint on number 4. Number 4, they're asking you to find the area. Do not get so super confused by this. We have a triangle. We have another triangle. We have another triangle. And we have a rectangle. Those are the 4 shapes that you need to find. And then when you add them together, you have the whole shape. You are not counting this section. This section is, it's a dotted line, so it doesn't count. You're only counting inside of the main shape, right? So give that one a chance. Like I was saying earlier, go ahead to that math website and look for the homework video for Module 5, Lesson 4. That should support you. I will not be posting that or creating my own video about that. Right? So after you have completed this lesson, what you should be doing next is trying out the, of course, the problem set, like I just said, and then you're going to jump over to the exit ticket and you're going to work out those problems. Don't do it in your head. Write it out. Either print out the exit ticket paper and then work it out there, or if you can't print it out, open up the exit ticket on a new tab and then work it out on your notebook. Good luck, guys.